so we're gonna talk about a project we were doing together. And as you already know, it's about open source tooling. So open source has this nice feature that all of us can use it. So hopefully you will find some useful outcomes out of our talk. So just a very short introduction about the project itself. The name JTAN stands for Joint Threat Analysis Network. So fancy name for open source development. But I think what's worth emphasizing is that we have several national level CSIRTs in Europe working together on open source development, and that's I think I'm very happy that happens, and that we can really work on kind of this public the project that benefits the public can benefit from. So we have Austria, Estonia, Latvia, Luxembourg, Poland, Romania, and Slovakia on board here, and yeah, we have the my team has the pleasure of coordinating that. And what we try to do with our contributions to the tooling ecosystem for CSIRTs, and not only for CSIRTs, these tools are more general security tools, is handle like collection, analysis, and exchange of information. So for collection, we would like to make it easier to centralize collection of threat intelligence, but also go beyond that and to work more with collection of facilitating collection of raw data for analysis, to help analysts with working with all the things that have been collected, and for information exchange. I think the main message would be lowering the barriers for information exchange, because even to make it as easy as possible and to make information exchange a sort of a default mode of how CSIRTs collaborate on the operational level. And one of the things that we identified some time ago, and maybe it's not everyone would agree with us, but that's our point of view. That's for sharing of threat intelligence, you already have means to do so. You already have like some good practice mechanisms, formats, and tools. So if you're not sharing threat intelligence, it's not the lack of tooling that is holding you back. But there is still not enough sharing, and things that are especially affected by this limited sharing is not uncurated intelligence or raw information that all of us collect for our own purposes. But what typically happens is that we share some TTPs, some IOCs, some advisories, but we rarely share the data that support our analysis. And so one of our messages today will be that we believe that sharing of raw data is something that should be done on a more regular basis, more often, and we also show some cases where it can bring some benefits. So I'll hand over to Charlie, yes, to talk about one of those cases.
Yeah, so the first use case we identified is which one? This one? What? Streaming. So yes, at CIRCL we have different services that usually people access via APIs, and we wanted to share the raw data behind those services. So for instance, we already had some kind of data link between the CIRCL and CERT.PL over WebSocket that was built with basically bash scripts and cron jobs. So we wanted to have the same kind of things, but kind of streamlined, something really easy to set up and that people can easily use. So we wanted to have this for passive DNS first, and also for the newly seen IPv6 addresses, some certificate transparency stream that we could expand and enrich with more contextual information or historical information. Also, as we have a passive SSH service, we wanted to stream the SSH public keys we see, and also scrapping data, because we scrap a lot of things for verifying phishing websites and stuff like this. All of this has value because you will be able to replicate this locally. So we'll be able to, if you have this service locally, you can hammer the service like it's not a remote service. You can really go hard on it. And also something that is nice is that you will discover new data. Like it's like serendipity. When you search for something, you find out something else. Here you will get access for instance, geographically data that are not relevant to you directly, but still that may be useful at some point. So you will get this data, find something sometimes useful. So that's the idea. So the main issue we had with this was really the maintaining the software. It's not the software, it was bash scripts. Create accounts and see the state of the link. Like we had also different protocols, like using Redis or WebSocket or whatever. And also we wanted that people could contribute back to those streams. So that was one of the points we had. So we wanted to have some kind of public facing data broker that people could actually contribute to and use. So to that end, we created something called Cocktail Party. So it's still ongoing development, still refactoring and everything, but we have an instance that runs. And here the idea, so it's something written in Elixir, so it's based on Erlang. So the rationale behind this is that we used Kalidoc Surf Stream for years, and before that, the version in Python, and we had issued with it. The guy rewrote the thing in Elixir, and the thing is now rock solid. So we were like, okay, we would like to have the same thing, more or less, but for every stream we have. So that's why we wrote this in Elixir. So with the Phoenix framework, that gives a lot for free, like WebSocket support, user management, everything. And really, it helps us to streamline this whole subscription thing. So here, the idea is that you would have users on the right, services on the left, and we wire our services or data sources to those services on the left. And users just get a WebSocket and they actually join channels saying, okay, I want to get D4 data. So D4 is the network telescope. Passive SSH keys, new IPv6, new onions, whatever comes from N6, for instance, for CERT.PL, passive DNS, but I don't want phishing or something like this. And then they will get a WebSocket with everything crammed inside. And also something else, for instance, here I put on the passive DNS with the red arrows, try to symbolize this, that people could actually push in those channels. And then we have ways to actually filter out the things. So you could have some kind of packet clearinghouse saying, okay, those packets, we want first to check those before pushing to the others. Or you can also fast lane this directly to everyone, like to put this in the stream. So maybe Paweł can tell you.
We also run some numbers on, so it's a pretty short experiment, let's say here for about half a year, where we looked how data from that we obtained that way from passive DNS monitoring by CIRCL, so Luxembourg focused, contributes to our anti-phishing efforts. We are running a country level DNS firewall, which in itself could be topic of a different talk. But the important thing here is that one of the elements, one of the inputs that we have for our process is that we collect domain names from many sources, and then we try to identify which of those domains might be phishing sites and add them to the DNS firewall. So having a good feed of domains is definitely something that we are always looking for. And I here on the slide, I provided some numbers of which data sources that then provided domains that ended up identified by our analysts as actually hosting phishing and listed in the DNS firewall block list. You can see that like it's very much dominated by certificate transparency stream, which is not a surprise. It's I think the most well-known data source for that kind of information. And then we have a couple of others, especially the zones for different TLDs. The GTLDs have a big, well, the second place, like a far second place, but still a significant contribution. A .pl zone. We have also a commercial provider for like a passive DNS data, and CIRCL passive DNS is like pretty low on the list. But how can we interpret this result? So it can see that 0.67% seems like pretty low, but it's not, I would say it's not low enough to be negligible input, especially if you think of the certificate transparency stream as something that is this has a bit of latency, because the domains appear there only after the certificate has been issued, compared to passive DNS sources, which provide a stream of domains as soon as they kind of appear in the monitoring. So it depends if so it's usually, it can be from resolving or crawling combined with resolving and so on in this case. So it can be, they can appear earlier in this source, and then even if it's like a small percentage, as long as it's this data comes earlier and it's also unique at the time, it can be valuable. So even if like it's a small number of sites, if it adds as even a handful of phishing sites, if it allows us to identify even a handful of phishing sites that we would not identify otherwise, it can translate into actual preventing significant financial loss, at least from the perspective of the victims. And also, another way to look at this is that this data source is like provides data from monitoring that is focused on Luxembourg, and it also shows you that there are regional differences from the campaigns that we see in Poland, and the campaigns targeting or the monitoring activities that CIRCL is doing for Luxembourg. This kind of confirms the regional differences and the need for having like diverse perspective for monitoring.
And Luxembourg is not really a big country, so the second use case we have is sharing automated event with MISP.
Yeah,
Sure.
Alex. Yeah, the thing that we did during the JTAN network was to evaluate all the collaboration mechanism that we have, and especially protocol standard communications that we are actually using between the different CSIRTs that are members of the JTAN networks. And what we have seen is actually a thing that we were finding challenging in using MISP for the sharing of, I would say, raw data or data which is less valuable. As an example here, we can see there the MISP event where you see a lot of correlations that are due to a lot of false positive. So the thing is there, it can be confusing for the analyst. So if you have like a dedicated MISP between different national CSIRTs, those information might be confusing by the other receiver. So the analyst might confuse the data and be lost with the different things. So during the project, we were like, okay, but how can we solve that? So to benefit from the raw sharing of information through MISP and find a way to make it easier at the end. So we basically did a very interesting exercise. So the CERT in Poland has a very nice malware database, which is basically a very active feed of information about malware configurations, IOCs and so on, but they might contain a lot of false positive. So what we decided to do is to basically set up multiple dedicated MISP that were covering a specific use case. And for the JTAN part, we had one dedicated for those kind of raw intelligence. And the thing that we did is basically to extend, even we did some extension of new features in MISP to basically have the caching features. So the idea behind is the following: instead of having the complete actual data, you have some relevant information like the correlations and so on, without the complete information. And if the analyst need to go further and to have more information, then he can selectively choose a specific MISP event, import it into their own MISP instance, and basically do the analysis or the investigations. So it's really nice because then you basically benefit from the other information. So you really benefit automatically from the trade intelligence from the other way. And that's the cost of reducing the cost of analyst fatigue. On the other hand, what we discovered too, it's interesting even to get that raw data to generate lists that will be used then as an exclusion list. So maybe some of you are familiar with stop words with indexer, and you can do the same with correlations. And the idea behind is the following: is by using those building lists of correlations from those raw data, you can basically improve the correlation table from the other MISP with intelligence. So we have seen that even mixing the two data sets give us interesting use case to reduce the false positive rates on MISP side.
Yes. So ultimately, maybe we'll have correlations that are warning list aware or something like this. Yeah. So the last use case we have was to how to share data that we don't really want to share openly. So for instance, information about harmful content, like link to season material or stuff like this. So one of the use cases would be, for instance, to filter out this content on a reverse proxy, for instance, for analysts to go on the darknet. So to that end, we created the private search sets that are basically a Bloom filter in which you encrypt whatever you put in it with some metadata. So Bloom filters are data structures that are probabilistic. So it means that you will, for instance, query this Bloom filter asking, do you know this string? And it will either tell you yes, maybe, or definitely not. And so we use this to have also some kind of plausible deniability, because it may not be in the set when it says that it is. So you can use that to do lookups and also doing like offline search. So if you have an online service, you could actually export this into an offline Bloom filter. So the idea is this one. So you have your analyst who use this proxy, try to access an onion on the darknet. This goes to the Tor2Web proxy that will check the private search set with all the bad onions. And if there is a match, it will just filter out the request and say, no, you cannot access this onion website.
Yeah, this example is really for helping analysts to avoid going to content that you don't want to see, but that example can be applied to a lot of other use cases.
Yes, even for moderation, we could use the same system. So how do we produce those filters? Basically, we have one of the sources, Ale project. We will talk just a bit about it later on, but the Ale project will crawl a lot of things from the darknet, and we have the ability to run analyzers on this and tag manually. So we can have automatic tagging and manual tagging, and everything that is tagged can then be put in this kind of filters, and the filter is used later on to filter out those requests. It can come from MISP, it can come from someone with a computer, and then anyone can do lookups on those filters. So
everyone can produce those lists. Could be CERT, like the JTAN partners, but it could be commercial vendors that want to provide feeds without actually providing the actual data, but just the private set.
Yeah. So where we stand now with private search sets, it's something we have some kind of standard that we want to on which we want to have some kind of IETF draft. And it's already integrated in MISP, so you can actually export some attributes and push them into these kind of sets. And also in Ale, when you do some, because Ale acts as some kind of data sieve, so you say, okay, I want to, a bit like Yara retroent, like you have this way of grabbing data when it passes through the system. Here you can use those filters to say, okay, I want to grab everything that matches this filter. So it's already implemented in Ale. And later on, we would like to be able to have this kind of filters in MISP. So in the next major version of MISP, here the idea would be to be able to do correlations between communities that don't really talk to each other. So like they don't like sync between those communities, there's no sync, but you could actually do the cardinality of the overlap between those communities. So then you could maybe conclude that those communities should talk at some point. And yes, we also want to have other data structure, but it's more implementation details. So there is also something else with those filter here in this case. For this safe Tor browsing use case, we use Bloom filters. But these Bloom filters can also be used for CTI analysts, for instance, when they want to filter out all the goodware before working on the machine. So check out ashlookup.io if you haven't, because I think we presented this 2 years ago, but it's just a side note. And then we do the highlights.
Our special guest is appearing. But we'll start off with Ale, maybe.
Yeah. So maybe some of you know a bit Ale because this was a presentation on Tuesday we did about Telegram monitoring with Ale. So Ale is an open source project for doing analysis of unstructured informations. It comes with a set of feeders, crawlers. So it's a tool that we really use for actively monitoring data from unstructured information. So that could be website and so on. So usually it's a kind of prime or pre-investigation analysis that will be used then later on to be distributed within JTAN networks.
Okay, so that was one of the projects that we developed further in the JTAN. Then Graphoscope that was this is developed by CERT.LV, which is a more analyst-oriented tool where that allows you to have to integrate multiple data sets and then have a visual graph-based, as the name suggests, way to visualize it and to have this also programmatic queries as well on those data sets. So that's very much a tool that an analyst would use for investigative purposes. And then I'll give the floor to Milan Pikola from SK-CERT.
So our contribution was more work on our tool Taranis NG, which is being used for analyzing the information and creating situational reports of various kinds. So the tool can ingest various kinds of input. It presents it to the live analysts who create structured reports. We have a lot of plans to add many ways of automation. And when we are talking about sharing, it also has several ways of sharing from team to team.
Okay. And one more thing is MWDB that was mentioned. It's the malware repository and repository of all information about malware. So we had a training on Sunday. Maybe some of you have attended the training that included MWDB. So for the rest of you, well, it's not your private virus total, but it can be a building block of one, if I can say so. So it allows you to centralize in your private infrastructure all kind of intelligence that is related to malware, including samples, but also to connect multiple analyzers that you have, and that's how we use it. We have an entire automated analysis pipeline that feeds information into the centralized platform, and then we also use it for sharing with the wider analysts and researcher community. And I think final tool we would like to highlight from our project is FlowIntel.
Yeah, during the development of the JTAN project, we were basically missing a tool, which is a tool for managing our whole flow control that we have, or process for trade intel and so on. So we decided to basically design a new tools. This one is quite new. It's called FlowIntel. The first part of it is basically a case and task management to manage basically all your coordinations within your team and the others. It's completely written in Python. It's basically a new tool. The idea behind is to help security analysts to organize their day-to-day work. As an example, we use it, for example, to coordinate our data sources from different use cases. But for example, in this case, we have forensic case and we do templating. The idea behind there is to share actually the templates among the different CSIRTs. And the thing is basically interconnecting with MISP and other tools like the MISP modules and so on, which basically helping the analysts to structure their works and to basically make repeatable works that you can do on a day-to-day basis.
All right, so that was a bit of a mix of what we did in the project. I hope it was not too overwhelming, but to sum up, I think that there is for many of the teams out here in the room. I hope that you'll be able to find some value in the open source tooling that we improved in the project. So in nutshell, these tools should be pretty generic, so they're not they're not very specific to our CSIRTs. The use cases they address are pretty universal. Many of the teams have services that somewhere in the backend require that kind of tooling, and we believe that improving the open source offering is like beneficial for the entire community here. Also, we try to work on the interoperability aspects, and so to make it easier to interconnect those tools, also to connect to different data sources and so on. So you have this lowering barriers for information of exchange for exchange of information that we mentioned already, and it's also like I like to stress the modularity because you could see that there are like different things that have some integration between them, but each of these tools that we talked about stands on its own. So you are not forced into some big blob, big set of locked software that does everything. You can pick which open source software from this entire suite is useful for you, and deploy that. And also about the project itself, it lasted for some time, for close to 3 years. We are officially closing the JTAN project as such, but maybe in contrast, in some of the projects that were co-funded by various countries, we are making sure that development is sustainable, and everything that we talked about, these are like long-term projects that they have been already actively maintained, usually 4 years, for longer than the project itself was, the duration of the project itself. So this is like healthy, or these projects are pretty healthy in terms of the development and maintenance, and we very much are committed to develop them further on. So either we even have some ideas for other projects to secure additional funding, but in any case, we are committed to make them work in the years to come. And our request to you is to provide us with feedback. We're very much looking forward to hearing like any opinions on what works good, what could be improved, and of course even better if you can contribute code, because we are very open for code contributions as well. And our final slide is with the links. So this is a selection of created selection of links, the things that we have developed in this 3 years, or like not developed from scratch, but improved mostly. So I hope we have some time for questions if there are any.
Thank you.
Okay, any questions, suggestions, comments? We have some.
Hello. I'm a big fan of MISP and I use Hive. It's a question for Rockstar Dulaunoy. Do you know if you are planning to do some kind of documentation for L or Hive just a little detail for interaction between the two platforms and the next that are following?
Yeah, so those are good questions. We have a new document that we call Ecosystem of Open Source Tool, which basically include a lot of tools from the JTAN project, and especially the integrations. So this at the end of the project, we will, for example, make a list of the different ways that you can integrate the different tools. That's sometimes indeed missing to have a global overview pictures of the different tool sets. So how do you interconnect your MISP with other tools and so on. But obviously we will have one document this referencing all the different connections and so on for the different tool sets that are open source. That's obviously, but it's a good question. We can talk after and see what kind of integration, because like Pavel mentions, I think is important for the next step. We have to have a kind of clear roadmap on the different tool set of integrations. We extended during the JTAN project already some of the tooling. For example, Graphoscope has extension now for some tooling that we have at CIRCL. Same with MWDB, with other tools and so on, which is great. But we are still missing some connectors. So we are interested to know which one that are a priority for you, so like that we can implement it. Thank you.
Next question.
The question about the sharing the raw data is always kind of associated with the privacy information of sharing and kind of like minefield of GDPR and all that. So do you have any word of advice, what kind of who to talk to or what kind of protections to take if somebody wants to replicate the similar effort?
Yeah, so it's not something that we are unfamiliar with. So from the early European project that we had with MISP called MISP-NG, we did GDPR evaluations of how we actually share information. The thing that as a CSIRT, we are in a very nice positions because we have a legitimate interest and we have a legitimate use case. And actually the thing that we were doing in MISP for the exchange and synchronization is basically applying directly for what we do there on the JTAN project. Nevertheless, for raw exchange of information, if you scrap website and so on, you might have additional information that might be in special category, things like that from GDPR. Then in this case, you might need to review it if you have the legitimate interest to do it. But technically, for us, it's not really changing anything from what we were doing from the past years. It's basically just improving the, I would say, time to response, so the real-time aspect of those sharing of information. But we forgot to put that, that's a good point. But for example, the private search set is actually that, is a way to sharing information that we could not share before, because there those information will be completely private. But if you are interested, we can even talk with Jean-Louis later on about the benefit of using it, at least for the GDPR case. But if you're a CSIRT in Europe, it's fine. If you're another organization, then you might need some legal work.
Yeah, I can also add that I mean, obviously, that's pretty important aspect. I often see various organizations that are a bit paralyzed by that, and they prefer not to touch the topic at all, which is, I think, too extreme, as there are many data that do not contain PII. And so, for example, like with malware data sets, these are usually pretty safe. But also like some opportunistic attacks. So not everything contains PII in the first place. And then, as Alexandre explained, like even if it contains it, it's not a blocker. It should not be a blocker if there is a legitimate interest.
Thank you.